I guess before we dive into today's material, which there's a file to download, so you can go ahead and get starwood.xls downloaded if you like. You'll probably want to. Held an exam review yesterday. There were a good number of people there, so I thought we had a good discussion. It ended up going about an hour and a half, and so fortunately the recording worked. I wasn't sure if the audio came through. The audio came through okay, and so that's posted there. Is there any interest in having the TAs hold another review session? They've taken a very similar test last semester, or last time that they took it. But I haven't given them the details of this exam. I don't know what you're trying to hope to get out of them, but
if you give them the details,
yeah, that's
highly interesting.
So it sounds like the interest rate's going to be pretty low then. So, all right. So you've got this review session, but then if you've got other questions, maybe just work individually. They probably still have office hours, and come by. Okay. So go ahead and download starwood.xlsx, which I think I have downloaded. I'm going to open it. Again, XLSX just means this is an old file. I don't even remember where I got it from, but this should be. I'm going to go ahead and save it straight away as an XLSM. Just so I have kind of current structure. Starwood, I guess I'll call it Fall of 18, XLSM. Okay. The data that we have here is it's like locations of various hotels that are owned by the Starwood Corporation. And so we'll be using these distances here. These are the road distances between some set, I'm not even sure what set it is, but some set of Western region properties owned by Starwood Corporation. So today we're going to be looking at and getting our feet wet with a general term in programming called arrays. So first, just to kind of see here, how many of you already can use arrays? I know I can. Every time I get a paycheck, I look at it and I say, boy, I sure could use arrays. There's really not that many jokes here, folks. You got to take what you can get. So a few of you are already kind of familiar with the construct, and I'll take the rest of you, we'll kind of get you up to speed today. So you've never heard of it or whatever, that's fine. But just partially to help me remember what my first experience was like with arrays, because you may be in this same place, I'm going to tell you what happened the day I first learned about arrays. So my father, I'm not sure how much of this story to tell. My father was a builder. He's a general contractor. And we were visiting my Uncle Jim, who had a huge house in the avenues in Salt Lake, one summer. They had part of the house was divided off into apartments, and they had a guy who was renting their apartment in the top floor of their house, fell asleep smoking, and the house caught on fire. I was sleeping in the basement. And, my father came in to wake me up at 5 o'clock in the morning. He came and woke me up. He said, son, the house is on fire. And the firemen have asked us to evacuate. What he said. It was just calm, dead like that. My father's not a jokester at all, so I knew that it was serious business, but kind of looking back on that, it seems like really strange. Not like he thought I should get out, but some fireman thinks I should get out, and so he's just relaying that message along. So anyway, Uncle Jim hired my father to do the work to repair on the damage from the fire. They put it out pretty quickly. There was more damage from the water than there was from the fire, which is pretty common. And so they decided that he wanted to kind of, his house wasn't big enough as it was. It was probably 8,000 square foot Victorian home. And he said, well, we're building, why don't we go expand a little bit? And insurance covered part of it. But so, he paid my father kind of above what the insurance was going to cover on this, and part of my dad's compensation for that was Uncle Jim, who was a brilliant programmer, ran his own computer company, taught my dad to program. Dad's a builder, had been a builder the whole time. I learned how to be a programmer. My dad's pretty smart, but he was never a very good programmer. After he finished my Uncle Jim's house, Uncle Jim hired him to go work for him, and so kind of when I was 11, 12, 13, 14, my father worked as a programmer in Silicon Valley. That's what he did. And, but he never really was really good at it, and he was never really a very good teacher. And the combination of those two facts sometimes were just absolutely deadly. as when he first started to explain the idea of an array. So he said this. He said, all right, so an array is like pigeonholes. And I didn't know enough at the time. I was probably 12. I didn't know enough at the time to say, Dad, I have no idea what a pigeonhole is. No idea. And we probably spent a half hour for him trying to explain to me the idea of an array with a metaphor. I had no idea what was going on. And he said, okay, forget that. He says it's like post office boxes. Now here's the problem. I grew up in a rural community, so when he said post office boxes, he thought I understood like you go to the post office and there's a nice organized grid of post. I'm thinking, no, it's like the mailbox in front of your house. And so again, this is what I thought it was not very well connected to the thing he was trying to teach. After about an hour of this, I was in tears. I thought, I'm a moron. I can't figure this out. My father was in tears. My son's a moron. He can't figure this out. We gave up. We gave up. It was a sad day. Oh, but you're in luck because I'm a really good teacher, and I'm going to teach you what it is. Okay, so let's just take a minute and just talk about the English language word array. What does it mean? Just forget about any programming connotation to it. What is an array? You know, if could you use? It's probably not a word you use in normal conversation. But if you were to use it, what would you say? Can you give me a definition? Just what is a definition? You can even look at Google. I don't like it. Give me something else. And you said something there, an array of tools. So that's the first thing we want to realize. When we're talking about an array in the word in the English language, it is always an array of something. We never kind of walk into a room and say, "My, what a nice array!" Right? Because to make sense, it's got to be an array of something. Google array. Just give me a definition. Go. You got it in the back. Go ahead. An ordered series or arrangement, like a collection. Yeah, it's a bunch of something that's organized, but it's always of something. And so I could look here and I could say, I want a fine array of students, or I might say a fine array of computers. I can see an array of a fine array of desks and chairs, but it has to be an array of something. Now here's the thing: in programming, when I say an array, it is always an array of something. What? It's always an array of something. But the of something is always exactly the same. It's an array of something, but it's not like I can have an array of one thing, an array of another thing, and it's always an array of, and for whatever reason, almost every book I've ever seen that talks about the idea of an array, they just say, here's a thing called an array. They never say what it's an array of. Good luck, because I'm going to tell you what it's an array of. Are you ready? In computer programming, when we talk about an array, we're talking about an array of variables. That's what it is. It's an array in VBA or any programming language. It is what was the definition again up there? That's enough. An ordered series of variables. And so we already know how to work with variables. Now we're saying there's a way that we can take a potload of variables, an ordered series of variables, and treat them uniformly. And so we're looking at working with variables now, instead of working at them one at a time, to be able to say, oh, I have an array of variables. I have an ordered series of variables that I'm going to be able to use. And so that's the direction that we're headed. Are we ready to actually do it? Let's get down to business. So, you know what? Before we get into that, let's talk about the context of the problem that I want to start solving today. So imagine, just suppose that you have been hired by the Starwood Corporation, for their Western regional office or something. I don't know, graduating with your MBA, your accounting degree or whatever, and you're going to work for them. And your boss says, okay, no one knows that I've hired you. And we've got these 35 or 36, I guess 35. How many are there? I think there's 36. 36. We've got these 36 properties that we'd like to kind of take a closer look at. And since no one knows that you work for Starwood Corporation yet, the first thing I'm going to have you do in your job is I'm going to have you go to all of these hotels. You got to go to all these hotels and get familiar with how they're doing. We're going to give you the corporate card. You're going to eat at the restaurants. You're going to spend some time with the masseuse, at all these places. Go and do this. And you look at this list, and you're like, there's 36 of these things. It's going to take a long time, and I got a family. I don't want to be able to take your family with you. We'll rent you a minivan or a not-so-minivan, and just go. Okay. And so you say, well, what order you want me to go to these hotels in? What's the answer? I don't care. But just you got 3 months before you actually show up here at the office, and during that 3 months, I want you to spend some time at these hotels, take some notes, what things are going well, what things aren't going so well, and that'll kind of be the beginning for when you get here. So you're going to decide what order to go to these hotels in. Give me some feeling about how you would like, what's a characteristic of the route that you're going to choose? You'd like the route to be what? Yeah, kind of like the shortest route possible. Why? Because every minute in the minivan with the kids is one less minute with the masseuse. Right? You got to choose where you're going to spend your time. It'd probably rather not be in the van. You got to go to all these places. Okay, so how are we going to do it? How are you going to decide what the route's going to be? Any thoughts? Talk through me in English. You could, if you want to give me some kind of an algorithm that you could use, that would be great. Or, how would you do it? Go ahead. Okay, so you've noticed that what we're showing here is that we've got, we have the distance between every two hotels. So between the Sheraton in Salt Lake City and the Sheraton in Los Angeles downtown, it's 691 miles. And in fact, I can see the distance between the Los Angeles property and all the rest of them. They're right here along this road. So that's the information I have. I have the travel distances, the road distances between any pair of properties. I got the distance between them. And so ultimately, we'd like to use that information to find the shortest path. Okay, so any thoughts for an algorithm? How might we go about it? I'll get you started. Start in Salt Lake City. That's the closest one to where we are right now. So okay, so start there, and then what? So we had a suggestion here. Go ahead. Okay, good. So what you're saying is, right. This is a pretty good algorithm. So the idea here is we're starting in Salt Lake City. Just look across and find who's the closest one to Salt Lake City. And then go there. And it's really the closest one to Salt Lake City that we haven't been with. Because which one is closest to Salt Lake City? Salt Lake City. But we've already been there. So find the closest one that we haven't been to yet, and then go to that one. This is a named algorithm. This is called the next nearest city algorithm. By the way, this is an instance of a famous mathematical problem called the traveling salesman problem. It's one that humanity has been studying for close to 200 years now. And mathematicians have dedicated their careers to figuring out how to solve this problem in various contexts. So we have here the next nearest city or the next nearest hotel algorithm. It is virtually guaranteed not to give us the shortest route. It'll give us a route, and it's an algorithm that we can calculate it, but it's not going to be the shortest route. The likelihood of it being the shortest route is very nicely approximated by 0. Unless it's a really trivial set of locations you're trying to go to. We're going to come back to that one, though, here in just a second. Other thoughts of how you might come up with a different route or even the best route? In the back? Just put all the properties into Google and say, Google, plot this for us. Google will do that for a few properties, but it won't do it with 36. The problem, that problem is too big for Google to solve. So that's pretty good, but it isn't going to do it for us. I like the approach, but won't do it. Okay, so here's the thought. Just calculate every possible route and pick the shortest one. And that is the only known solution to this problem. So we've been working on this as a species. We've been working on this for well over 100 years, close to 200 years, and that's the best we've got. Well, I'm not saying it's the best we've got. It's the only known solution. Okay, how many properties do we have? 35 properties? 36 properties? Thank you. So the question is, how many routes are there? I'm always surprised when someone can just throw this right off the top of their head. How would you figure out how many routes there are? Yeah, 36 factorial. When I figured out it was 36 factorial, it took me quite a lot of thinking to come up with that. Oh, it's 36 factorial. Fortunately, there's a function here in Excel called fact, which will give you factorial of whatever you give it, 36. You know, I never was 3.7. I never was so good with scientific notation, so let's put this as a comma. There we go. I guess we don't need the decimal points on it. So, oops, I went the wrong way. There we go. That's how many different routes there are. And this problem is only 36 properties, but that's how many different routes there are. So one time I thought, okay, I'm going to solve it. I'm going to calculate the shortest route. And so I set my computer to solve the problem, wrote an algorithm to go and just calculate this route, change it, calculate the next route, change it, calculate the next route. And I let it run for a couple of hours and it didn't finish. And I thought, I wonder how long it's going to take. So I interrupted it and I calculated how many routes my computer was calculating in a second. I was pretty impressed. It could calculate 5,000 routes in a second. So let's just find out what's going to take to solve this problem. I'm going to take this, and I'm going to divide it by 5,000. Whoops. This divided by E2 divided by 5,000. That's a lot of seconds. I better get to minutes. Divided by 60. Divided by 60. I think we're now to hours. Whoops. This equals this divided by 60. There's hours. Let me get to days. This divided by 24. That's how many days it would take. Wow. I don't even know how to say that number yet. Divided by 365.251. That's how many years it's going to take. That's how many years it would take my computer to solve this problem with the only known algorithm to guarantee me the shortest route. One computer is not going to do it. I read not too long ago in PC Magazine that the 1 billionth computer, the 1 billionth PC had been produced. So I'm just going to take that as a surrogate for the computing capacity of humanity. We'll take, oops, come back. We'll take this is equal to this divided by 1 billion. 1, 2, 3, 4, 5, 6, 7, 8, 9. So if we put all of humanity's processing power against this problem, it's still taking that many years. Best scientific estimate for the age of the universe. We got to get this down to a number we can think of. Anyone know? Like 20 billion years. So that's kind of a high estimate. So divided by 20, 1, 2, 3, 4, 5, 6, 7, 8, 9. Ah, finally a number I can understand. That is hundreds, thousands, millions, billions. Okay, this problem is so difficult to solve, it will take 117, if we were to dedicate the whole processing power of humanity, it would take us 117 billion times as long as the universe has been in existence to solve the problem. You could drive the worst route faster than you can calculate the best route, right? Really, like way faster. So this is the problem that we're not going to come up with the best route. Now, so how is math, this is the best they can come up with? Well, so the kind of whole work we do is, how can we throw away large parts of this problem and be relatively sure that we haven't thrown the best route away? And so they're trying to find ways to get through this a lot faster and still be relatively sure that they've got the best route there. Now, let's add some complexity to this. By the way, who's really interested in solving this problem? What company has to solve this problem thousands of times a day? Well, yeah, Google, because people are asking you to. Yeah, UPS, any kind of delivery company. They've got a bunch of stuff. They've got addresses they've got to deliver. They've got resources that they're trying to minimize the consumption of resources. Now let's make the problem a little more complex. If I'm driving, I'm driving my UPS truck. I'm delivering stuff. Would I prefer to make left turns or right turns? Right turns by far. Left turns they're more expensive because they take longer, more likely to have an accident. There's all kinds of reasons I would prefer a right turn over a left turn. So now add the complexity to this. It's not just what the distance is, but now I have to add some other kind of incremental cost for a left turn versus a right turn. You see how the problem gets really, really complex. And by the way, how would you really solve this problem, the one that I described? You just take a map. Yeah, just plot all these, take a pencil and go, you know what? That's how I would do it. And it would be a really, really good route. Probably better than the route that we're going to calculate automatically here because we're going to use the next nearest city algorithm. We're going to implement that in class. We'll get it started today, and that's where we're headed. So, you might look at this and say, well, I can do better than, I can do a really great job with a pen and pencil, but what's the problem with taking a map and a pencil? What's the problem with a map and a pencil? It's not scalable, right? If I only have to make one route, that's the way I'm going to do it. But I have to make 1,000 routes a day. You just can't do it. You can't do it that fast. So that's where we're headed. So our goal here is to be able to calculate a route that I can drive that will be better than the worst route, that will still go to all these properties, and we're going to use the next nearest hotel algorithm to do it. And in the and kind of in so doing, we're going to get experience with arrays of variables. And probably from now on, I will probably, just like everyone else, only call it an array. But maybe from time to time, I'll remind us that we are talking about an array of variables. All right. So I am, there's no modules in here, so let me go ahead and insert a module. Now, actually, I'll give you this little tip here, is that there's no question on this on the exam. But the study guide asks you some question about the difference between a module level variable and a local variable. So kind of for the first time, let me introduce that idea to you. So far, every place that we have declared a variable, let's go ahead and make a sub procedure here. I'm going to call this init, I-N-I-T, init arrays. We're just going to initialize our arrays. Every time where we've declared a variable, dim hotel, as a string, the only place we've ever done it is inside a subprocedure. And when I declare a variable inside of a subprocedure, when does that variable get allocated in memory? Do you know? Yeah, when this subprocedure runs, not when I start to run the program, because I could have thousands of subprocedures here, and the interpreter doesn't know which ones I'm going to run. But it says if you're going to run this subprocedure, okay, hold on a second, let me look through here and find where all the variables are, allocate the memory for that, and all those variables get allocated, and then it starts running that subprocedure. And goes through, and when it hits the end sub, when it's done with that, what does it do to all that memory? It releases it back to the operating system. I'm done. I just needed this for the subprocedure. That's what's called a local variable. It's declared inside the subprocedure. It's accessible only inside that subprocedure. And so if I had some other subprocedure, or down here maybe called calc route, subcalc route, then this subprocedure has no access to that variable. That variable is only available from lines of code inside the subprocedure. Local variable. That's nice. The reason that's nice is that I don't have to worry about accidentally using a variable that by the same name and changing its value somewhere. That's pretty a good thing. Now, what if I wanted to have something that was available from both of these subprocedures? I don't want it to be a local variable. I want it to be a module level variable. It's really easy. Are you ready? All I do is move the declaration from inside the subprocedure to up to the top of the module. And now this is a module level variable. It's available to any subprocedure in this module. And it used to be the only word we could use to declare variables was dim. But then they said, you know what, let's make a couple others. So this would work just fine. I'll put these in and we'll take them away here in a minute. We can also say private, P-R-I-V-A-T-E. It only makes sense at a module level, and that says this is really only available to this module. But if I wanted to make it available to other modules, code in other modules, what would I say? Public, yeah. P-U-B-L-I-C. So I can say dim, private, or public, and that kind of controls the scope of this variable. Where is this variable allowed to be accessed from? I'm going to stick with dim for us today, just because that's the one we're familiar with. Question here. Well, so the question is, what would happen if I put public here, public x as integer? I'm not even sure this is allowed here. Let me try to run this and see what it does. Yeah, you know what? You can't put public. You probably can't put private either. Let's try it. I mean, it makes sense to call it private in the inside because that would be the right kind of scope, but I'm not sure it's allowed. Let's find out. Yeah, you can't do that. So public and private you can use at the top of the module, but not when you're declaring it inside the subprocedure. Question over here, go ahead.
So with public, you add variable
That's right. So, so if I say dim or private here, this is only available inside this only available to sub-procedures inside this module. But if I change it to public, then I could have 3 or 4 different modules, and they could all have access to this one variable. I'm kind of controlling where I have access to the variable. Okay, now, so I'm still declaring a variable here, but I'm declaring it now as a module level variable, but it's the same, right? It's just, how many variables have I created here? Yeah, just one. It's some location in memory, and it's called hotel question. Oh, does dim have some kind of default scope? And the answer is, yeah, private. Dim is like private. Yep. Okay, in fact, here's a little trick. In the very early days of BASIC, you didn't declare variables at all. You just used them. And you could do but by how you named them, you could do something to kind of say what type they were. But we always had to declare our arrays. Is that a question? I'll get you in just a second. So we've always had to declare arrays. And from the very beginning, when you made an array of variables, you use the keyword dim. Dim is short for dimension. I'm setting up the dimension of my array of variables. It's allocating memory. And so when they said, oh, we're going to let you declare variables, they just took the same word you used for making an array of variables and used it for making a single variable. That's where the word comes from. There's a question in the back. So the question is, does the module have to be open for other procedures in other modules to be able to access it? And the answer is, it has to be in an open workbook. But in a sense that I have it open here for editing, the answer is no. Because I don't have to have my editor open at all for this code to be able to run, right? I could create all this code, put a button that works it from Excel, and it can just execute without even the editor being open. So yeah, there's no notion that the module has to be open to be accessible. It's just, it's available. Okay, so here's the difference. If I want to make an array of variables, all I do is right after the variable name, I put a number. I want to make a bunch of hotels, I'll put a number in here. Now I have made an array of variables, an organized listing of variables. What was the definition? I don't remember anymore. But now, with the same one line, how many variables have I created? I haven't heard the right answer yet. 101, yeah. Oddly enough, when I put 100 here, it doesn't create 100 variables. It creates an array of variables whose top index is 100. And where do arrays start counting? They start counting at 0. And so I have a number 0 element of my array, and then I go all the way up to 100 here. As it turns out, let me just kind of give the disclaimer here. As it turns out, I can put another compiler directive up here. So we have option explicit. I can put option base 1. If I put option base 1, that says, you know what, why don't we just start counting at 1? Can we start counting at 1 instead of start counting at 0? That's what this says. And so you might be tempted to say, oh, you know, this is easier for me to think about. If I don't have to think about 0 being the place where we start, I'll put option base 1. So now, because I've told my compiler, hey, our base for arrays is going to start at 1, now how many arrays or how many variables are in this array? 100. But we are not going to do that. We are going to leave that off, or if you really want to put it, you can option base 0 is the same as not having it there. That says our arrays are going to start counting at 0. And here's the reason. Is it a little more difficult to learn to work with arrays if they start counting at 0 than at 1? The answer is yes. But if you have learned to work with arrays with an indexing scheme that starts at 1, if you learn it that way, and then you come across someone else's code that starts with 0, it is a nightmare to try to make that transition for you. But if you have learned, taken a little extra effort to learn to work this with a 0-based scheme when you begin, when you come across someone else's code that uses 1-base indexing, it's a breeze. So we're going to use 0-based arrays for 2 reasons. 1, you'll learn this stuff better. And 2, this only counts for arrays that you declare. We're going to see that there are some properties that are themselves arrays. We've seen properties that are like strings. Like an address is a string, address of a range. We've seen properties that are like numeric values, like the value is a number. we've seen some properties that are collections of objects. We've seen some properties that are objects. We can have a property that's an array of variables. Guess where that property is going to start counting? It's going to start counting at 0, and there's nothing you can do to change that. So we're just going to say, let's just treat all arrays as zero-based arrays for this class, and so we're in good shape. So one little trick here is that doesn't create 100 variables, it creates 101. I'm showing the top index that I'm creating here. Okay, so that's the neat thing. It's just one statement. It's just exactly like declaring a variable. I just say I'm declaring a bunch of variables, and I give it a number to indicate how many I want to create. There's a question here. The question is, could you change the size after you have created it? The answer is yes and no. But since you brought it up, let's go ahead and take a look at it. If I tell it how big I want to make it, if I tell it the size right here, on where I'm declaring the array, this now becomes what's called a static array. I cannot change the size of this array. The array is done. I am done. I've got a whole bunch of variables, and I'm not going to change that. But I could create this as a dynamic array, which since you asked, we're going to do. Here's how you make a dynamic array. Are you ready? Gone. It's exactly the same. I just don't tell it how many. Now, before I can use this now, I've got to tell it what size I want to make it. But because I've made it a dynamic array now, I can change the size through code. Which means I could figure out how big I want this to be and then make the array that size. So why don't we just go ahead and do that? So and it's reasonable because we can think, you know what happens if someone adds in another property here? They give us another property, they give us a bunch of distances for the rest of the properties. We'd like our code to still work. So let's go ahead and figure out how many properties are going to be here. So let me declare a variable here, a local variable, dim hotel count as an integer. We're probably not going to get above 32,000 hotels, so I think integer will be okay. Actually, byte would probably do. We're probably not going to do more than 255, but dim hotel count as an integer, hotel count, H-O-T-E-L, count, equals. Now, how are we going to figure out what the hotel count is? Well, we've got a worksheet here called distance. Let me go ahead and let's make a variable to do that distance sheet. So let me dim D as a worksheet. Set D equal to worksheets sub distance. Hotel count equals D dot cells. Now, which row do I want? I want to come, why don't we do this? Why don't we start on row number 2, column number 1, and from there I will say end XL down. And so that's going to say, as if I was on cell A2, hit control down, it would just go to the end of the contiguous data. So as long as I can be comfortable, I don't have any blank hotel names in here, that will find me that last row. And now I'll just, that will refer to the cell in that last set of contiguous data. We're okay with this? I'll ask for the row of that. And what's that going to give me? That is going to give me 37. We start counting, we don't have 1, so it's going to be actually, my hotel count is 36, so it's whatever row that gives minus 1. So now I have asked how many hotels are in the problem. And now I've got that value in hotel count. And so now I can redim my array and put the size I want it to be right here. H-O-T-E-L count. Now, if I want to have 36 elements in my array, what number do I put here? I put 35, so I better put hotel count minus 1. When I declare the array, I give it its type. And so I'm going to have as string up here on the dim. But when I redim it, when I give it its size, I don't tell it the type. I'm not changing the type. The type is defined when I declare the array of variables, but I can change the size with readdim, so there's no type. There's no type that goes out here. And I can readdim an array as many times as I want while I'm using it. So I could go readdim it again later on and say, oh, I don't know what happened. I need a few more hotels in here. I can readdim it again. But when I readdim an array, it blows away the old array and makes a brand new one. So any data that I have in there is lost, unless I put the keyword preserve right here. If I say readdim preserve, then it still does the same thing. It makes a brand new array, but if I say preserve, it copies all the values it can from the old array into the new array. What happens if I readdim it smaller? Can I still preserve? Yeah, it'll take whatever it can, but if there's no room to put it, it'll just, sorry, I can't put that there. It'll preserve what it can. Question here? Question is, why are we subtracting 1 twice? And when I'm picking up the hotel count here, I want to know, I really want this to be how many hotels we have. And so I'm subtracting 1 off here because I'm starting with a blank row. And so when I get all the way down here to row 37, if I do Control N down, row 37, it's really 36 hotels that I have. So this minus 1, it says you've got a blank cell that you're starting with, and so you got 1 less. But that really is the number of hotels. Why am I subtracting the 1 here? It's because I want to have the number of hotels in my array, but because arrays start counting at 0, I need to take 1 less off of the count. So I want my top index here to be 35. That will give me 36 variables in the array. Okay? Yeah, you might think, hey, he's subtracting 2 by mistake there, but yeah, it's 2 different things that we're having to offset for there. Questions? I don't think I've ever taught dynamic arrays as the first time through arrays, and I may repent of it later. It's a little more complex, because you don't just declare it as a size. Declare it, you figure out the size, you have to readdim it. But either way, by the time we got here, we have gotten to, we now have our array. We have an ordered set of variables. And you're about to see why it's really powerful. What I want to do is I just want to load up the names of the arrays, the names of the hotels, into the array of hotels. And so let's see how I might do that. So let me go ahead and dim x as an integer. And now let me just go ahead and I'm going to do a loop here. For x equals hotel count, 0 to hotel count minus 1. Next. I'll go ahead and put a do events in here because it's a good habit. Okay, I accidentally put myself into an endless loop, although the chances of doing that in a for next loop are really slim, but I'll go ahead and put it in there anyway. So now I need to come up with some line of code that will let me do this. I want to say hotel. By the way, here's how I refer to an individual element in that array. I want to talk about one of the variables in this array. So if it was just a variable, I'd say hotel count equals, and then put some. Is it Sheridan or Sheraton? I don't know. Anyway. Well, actually, there's one hotel here called the W. That's easier. Okay. So if it's just a single variable, it's a variable name equals whatever value I want to put into it. But if it's an array of variables, I now need to say which one do I want. How do I specify it? I just put it in parentheses right here. I want the very first one. I put a 0. So into my 0th position, we're going to generalize the code here in just a minute, but in my 0th position, in the first element, I guess I better call it the number 0. In the number 0 element in this array, I'm now putting W. Now let's go ahead and put a particular name. So that's going to be my distance sheet, row number 2, column number 1. So I'm going to put dist. What did I call it? No, I just called it D. So I have a reference to my worksheet just called D. D.cells, row number 2, column number 1. That's where that name is. Okay, so if you've got that typed in, great. Don't type this next part. This is just kind of an exercise for me to think about how to put this code into a loop. Even though it's in a loop right now, let me just think about it with actual indices. So I want to put in number 0, then number 1, number 2, then number 3. So here's my first 4 elements of my array, and I want this to be row number 2, row number 3, row number 4, row number 5. You see it? So, if I was just writing this all out, I would do, 36 of these lines, and I'd be able to get all of my hotels lined up. Now, but the whole point here is I've got a loop that's already taking this value x, starting at 0, and going to 35. Well, that's what I need here. So if I'm just trying to make one line do this, what is it going to be? What do I put here? Yeah, x. That's the whole point. So now the first time through the code, x will be 0. Second time through, it'll be 1. Third time through, it'll be 2 and 3 and so forth. What do I do over here? Yeah, or 2 plus x, or x plus 2, either way. And this now will give me 2 plus 0 the first time, which is 2, 2 plus 1, 3, 4, 5. So now I've built, don't really need those at all. So now I have a loop that's going to fill that array full of the names of my hotels. Here, this is the reason that arrays of variables are so powerful. I can have a large set of variables, and I don't have to treat them individually because I can use a variable here to talk about which one I'm interested in. And so I can make a loop that treats all of these. And that's why this is so much better than having 35 or 36 different individual variables. Put them in an array, and that array will let me make a loop that treats them all together. You see it? Okay, question here. Can you have an array of arrays? Now, in some languages, that would let you create it really gives you like a multi-dimension array. So I've got an array with multiple variables here, and then inside each one, I've got an array inside each one of those. And the answer is no. But you can, in VBA, you can create a multi-dimensional array. So you don't make an array of arrays, but you can say, I want this array to have 2 dimensions. So you can kind of set up that same structure, but it's really just a single array that happens to have 2 dimensions. And we're going to do that. We'll do that today. Okay? But let me get this to where we're putting the data in and then reading the data out just so we can see how it comes out. So by the time this executes, it will have put into memory at each one of those locations, each one of those variables, the name of one of these hotels. So let's go ahead and read them out. I'll do the same thing. In fact, I may just copy that block because it's almost the same. And as we all know, the less I type, the better it is for everybody. So I'm going to go again through that same range. And instead of reading the value in there, I'm going to just print out what is in the loop, or what is in the array. So the first time we execute this line in the loop, x will be 0. It's going to print hotel number 0. And then it's going to, in fact, let me go ahead and print the x as well. So x, comma, so it'll print 0, and then the name of whatever hotel is in the 0th element of the array. And then the next time through, x will be 1, it'll print a 1, and it'll print whatever hotel is in the number 1 slot in the array. Got it? Okay. I'm just going to go ahead and run this, and that should print out a bunch of names of hotels into my immediate window. There they are. Yeah, number 0 array, number 0 hotel is the one in Los Angeles. Number 1 is Salt Lake, so that should be right here. Los Angeles, Salt Lake, we're looking pretty good. There's a question? Oh, could we just put it here? Could we just take this line right here, and as soon as we had written it into the array, could we just print it out of the array? The answer is yes, we could have done that. I've separated this out just so we can see it, that it's separate from loading it. It puts it into memory, it's its own independent structure, and then later in life, I mean it's a millisecond later, but later in life, it can then print off, can go re-access that array and print off that particular one. You know what? If there's one you like in particular, you really like the one from Las Vegas, you could just have a line that does that. Debug.print hotels, hotel sub 7. I think it's number 7. And so that should print the whole list, and then it should print whatever the name of the Las Vegas property is. Yeah, the Westin Casuarina Las Vegas Hotel, Casino and Spa. How did I know it was 7? I remember this from the last time I did this example. Las Vegas is hotel number 7. It's a lucky number, lucky 7. So, okay, questions then here. Okay, so at this point, we've just seen an example of creating an array of variables and then putting a bunch of values into the variables of that array. So now let's take a minute and just think, how are we going to go about solving this problem? We've talked about the next nearest hotel algorithm in English. Let's kind of talk about it a little bit in VBA. So in fact, you know what might be kind of handy? I've got another sheet here, sheet 1. Oh, I've already created sheet 1. I'm just going to delete our little experiment here. I've got sheet 1. You know what I'm going to do? I'm going to also print these things out. You probably don't need to do this as part of solving this problem. This is just so I want to be able to kind of visualize this particular array. So let me kind of start this out in, I guess I'm going to just do it in A1. So we're going to print that out, and let me just do this. Let me just say, let's put it on the active sheet. So cells, row number x plus 1, column number 1, dot value equals x. And then in the next column over, I'm going to put hotel sub x. Next column over. So column number 2, hotel sub x. This is not part of the solution. This is just part of the visualization that I'd like to make to be able to talk about this array. So I'm printing onto this sheet a representation of this array. Let me give myself a little more space around here. Well, let me just kind of go ahead and put on here, Control Shift down arrow. Just put some borders on this so we can kind of see the structure that I'm trying to get after here. All borders. So this is like my array here in memory, right? Now, of course, it is in memory. It's not here on the worksheet. I'm just putting it out here so I can see it. So I now have kind of a list of hotels here. Go ahead and insert a blank line here, Control plus. So I can kind of see this and think of this as my array, a visual representation of the array, because that's one of the things about the array is that it's non-visual, right? I can't see it. Those variables, there's no way for me to look at those variables except to somehow to print them out. So I'm going to look at this and think, okay, so now I've got an array here called hotel. We'll just put the name here. And so I can refer to this. So this is going to be part of my solution for calculating my route. Because ultimately, I'm going to be able to print the route out. I'm going to need the names of the hotels. I'm going to say, go to this hotel, then go to this hotel, then go to this hotel. So now, let's think about how are we going to actually solve the problem. What else are we going to need to kind of solve this problem? Any thoughts? Somehow I'm going to need to create the order. I'm going to have to somehow say, go to Salt Lake City, then go to Las Vegas, then go to Los Angeles, and then figure out everywhere you're going. But there was a comment here. Go ahead. Okay, yeah, so we're going to need to do that. We'll do that with code. But right now I'm thinking about kind of what are my data requirements? What do I need to kind of keep track of this? And I'll probably want some other array here that I'll be able to use for the route itself. So let me go ahead and I'm going to copy these. And again, this is probably more important for you to see than to actually work along with me. You're probably better off just kind of looking at this and saying, okay, I'm following what he's doing than duplicating this in your own example. I'm going to call this array route. Now, ultimately, it's going to be an array, not a range. This is just so we can think of it and reason about it. I'll call this one route or root. I'm not sure. So, and this one's going to have in it what? What shall I put in here to be able to keep track of which one I'm going to first? How should I say start at Salt Lake City? How do I do that right here? How do I say start at Salt Lake City? I heard it. Say it louder. Yeah. 1 is, that's the number of my hotel. Hotel number 1 is Salt Lake City. So in my route, if I come here and put a 1, that says start at Salt Lake City. How do I say go to Las Vegas? Yeah. Then the next element in the route is going to be 7. And then I'm going to go somewhere to Los Angeles. I don't know which one it comes to in Los Angeles, but then it's going to be maybe 0 or something. And then that is, I don't really like the formatting here, but yeah, I really want that to be a 0. So I guess let's do it this way, 0. 7. Okay. And so I'm going to create another array. So go ahead and do this. Declare this array. Go into your code and declare this array, think about what data type is the right data type to use for the variables of this array, and go make a declaration that will handle this particular array. It should, hopefully it'll take you less than a minute to kind of figure out where to put that and exactly how to make it. You've got the name here, and we're only worried about the declaration. While you're doing that, I'll kind of build out the next part of this example that I want to show. Okay, so it's the same shape as my hotel, so I will just come to the top, dim route. We'll save the size later as not string. What is the right data type? Yeah, probably integer, maybe byte, but let's go ahead and use integer. Maybe we'll have a route that's longer than 255 hotels, but I'm okay. It's only taking me 1 extra byte of memory, so I'll go ahead and do it. Go ahead. Oh, yeah, so why aren't we declaring this inside the subprocedure here? And the answer is, the way I'm building this, I'm saying I want one subprocedure that just gets the data into the arrays that I'm going to manipulate. And then I'm going to have another subprocedure here that actually that does the calculation. And so I'm going to have 2 different subprocedures I want to be able to access these arrays. And so I want it to be a module level, these module level variables, so I can access them from the 2 different subprocedures. All right. So let me go ahead then. I'm going to redim my route. This is the same way that I redim my hotel. So instead of hotel, we'll make this route, and it'll be that's exactly the same size, right? My hotel's got all my hotels. My route has to have all the hotels as well. That's the numeric representation. So in this context, it took us 2 things. We had to set up the dynamic array, and then we had to redim it to be able to give it its size. Questions? How many of you got the declaration of the array just exactly right? And then how many of you also thought to come down and do the redim as well? Do you? Not as many hands as I wanted to see. Questions? Question here?
Yes, sir. Does it matter if
Okay, so the question is, we've got these dims. So first of all, if I'm declaring a module level variable, does it have to be at the top or could it be anywhere in the module? And the answer is it has to be at the top. So when I'm doing module level variable, they got to come after my compiler directives before any subprocedures. Right, yeah, let's come to this one. So then the question is, well, do I declare these variables up here, or could I wait to declare this x until just before I need it and put that right down here? And there are 2 schools of thought on this. This is legal. This is okay to do it this way. By putting it here, it says, hey, you can't use x above where it's declared in your code. Try to use it before you get to the declaration statement. It goes, that's no good. And so by declaring it down here, it says, okay, so x is going to be valid from this point on in my code. So that's kind of nice. But the thing to realize is that when the interpreter is looking at this subprocedure, before it runs a single line of code, it has to figure out how much memory do we need. It has to go allocate the memory. And so logically, where the dim happens, it happens before any other line of code executes. And in most languages, you have to declare the variables up at the top of the subprocedure. VBA lets you put them anywhere else, but logically, they're happening here before any code executes. And so that's it. So my preference is to kind of put it logically where it happens. But other people like to put it down lower, and there's a good reason to put it down lower, and you can choose. Either way you want to do it is fine. Okay. So we're going to need one more part of this solution, and that is, so now let's start to think about the algorithm. So what are we going to have to do to figure out who's the closest hotel to Salt Lake? We got to find out who the closest one is to Salt Lake. How are we going to do it? We have to look at all the rest of the properties. Now, truth is, with a little bit of work, we could actually come and read that right off the sheet here. But since we're learning about arrays, let's go ahead and put all of this into an array, and we'll use that to kind of help us get a little more strength working with arrays. How come I only got numbers on one half of this array? Because presumably the distance between Salt Lake City, the Salt Lake City property, and the Los Angeles property would be the same as the distance from the Los Angeles property to Salt Lake property. The truth is, it's not quite the same because somewhere in there is a right turn or a one-way street or something that would make this marginally different, right? If I actually plotted it with Google, which is where I got these. I just took these to Google and plotted them, and it told me what the road distances were. So it might be a little bit different, but that difference we're saying, you know what, it's insignificant. And so it only shows that. Sometimes you'll see like on a map, whoa. You guys even ever used a paper map? Like especially, you know, if you've got a map of like a country, it'll have a table at the bottom that shows the distances between major cities on the map. And it will show miles on the one diagonal, and it'll put kilometers on the bottom diagonal or something like that. So sometimes that's the way they do it, but here it's all going to be miles. So we're going to create an array to hold all of this information. You know, it's going to be 36 times 36, or 36 times 36 elements, however many that is. That's how many variables we're going to create. We'll do it with just one line that creates that. But should we declare this to somehow be a triangle, or should we make it a rectangle? This is an easy one because you can't make them a triangle. When you create an array of more than one dimension, all the rows are going to be the same size, all the columns will be the same size. So it's got to be rectangular-ish. And so let's go ahead and declare another variable for this one, another array, dim distance, as a dynamic array. And this one will make single. We need decimals here. Well, yeah, we'll take the decimals here. Yeah, single as opposed to double. So what do I need double for? Double is if I need a lot of precision. You know, either a really big number or a really precise number. In this case, we got hundreds of miles with 2 decimal points. Single is plenty. By the way, where's kind of the cutoff? If you need about 8 digits of precision, single is great. You need more than 8 digits of precision, kick over to double. Okay. Yeah. The question is that 8 digits on either side of the decimal point? Maybe it's 15. It's probably 15 digits. You probably we'd have to look it up, but you know, if you have anyway, if it's kind of on that order, you've got around 10 digits that you need. Single should be okay, and it doesn't matter where the decimal point is in there. I think it probably isn't 8. It's probably 15 decimal points that you get with single. Okay, so let's go ahead and redim our distance as well. Actually, let me do it as a static array just so you can see it first because the code is simpler, and then we'll redim it and you'll see how it works. So if I was just making distance like hotel, I'd put 35 right here. And that gives me a single dimension to the array. If I want 2 dimensions, I will just put comma, and then however big I want the next dimension to be. In this case, it's square, so it'll be 35, but it doesn't have to be square. I could have, 35 one way and 6 the other way. It would be, rows and columns. By the way, which one's first, rows or columns? It's a trick question because, in fact, there's no row and no column, really. Right? It's just a bunch of variables that are indexed with all these numbers to identify them. And so if you want to think of this, is it organized as a grid in memory? I mean, I'm looking at it here. It's like a grid. Is it a grid in memory? The answer is no. It's a bunch of memory locations, one right after another. It's a long string of variables. And so this is just for kind of us to be able to think about this. The answer is it doesn't matter. If you want to think of it as a square, great. You can think of it as a square. If you want to think of it as like a set of 36 boxes, and each box has 36 boxes inside of it, and the first number is the outside box, and the second number is the inside box, you can think of it that way. As long as you're consistent with the way that you think of the indexing, you'll be okay. So if you want to think of it as rows first, then columns, as long as you always think of it as rows and then columns, great. If you want to think of it as columns and rows, as long as you always do it that way, it's fine. As long as you're consistent, that's okay. Because it really isn't, it really is nothing more than an ordered pair. It's not a grid. It's an ordered pair. Okay, but we're going to make this dynamic, and so we'll come down and we'll redim this. Redim. Oh, you know, we don't need preserve on any of these. Let me leave the preserve off of this one just so we can have a little variety here. Distance. And now we've calculated my 35 here. And so we'll put that 35 in, 35. And now we've redimmed our distance array. Okay. How are we feeling about the two-dimension array? Let's go ahead and load it up with its variables, and then let's see how to access it, because now it's more complex. It's not just a single number which tells us which variable we want. Now we've got to supply two numbers to be able to get the variable that I'm interested in. So we could build this. Oh, you know what? While we're at it here, we're initializing hotel with the names of the hotels. Let's come here and initialize our route as well. What route is what type of variables in the array? Integer. So what value is going to be in every single one of those variables when it starts? Integer has a default value. If I don't tell it what to be, it's going to be some number. What number is it? It's going to be 0. And so, but I would prefer this to be something besides 0. Here's the reason. In my route, I'm going to have numbers. Right? It's going to be, here's hotel number 1, hotel number 7, hotel number 12. This is where you're going. What's the problem if I have zeros in there? Yeah, 0 is one of my hotels. And part of the algorithm, I know this because I've been through the problem before, but part of the algorithm is going to be, I got to look at that array and ask, have I been there? Have I been to hotel number 0? And if my route starts off full of zeros, what's the problem? Even though I haven't really put it into the route, it's going to think it's there already. And so let's put some value there that is not any of my, it's not the index for any of my hotels. So any number besides 0 through 35 will work. What should we put? 36 is okay, but I don't like it. 100 is okay, better, but I still don't like it. I heard it over here. What was it? -1, yeah. -1 is not going to be any hotel no matter how big this problem gets. And so let's just go ahead and drop in here -1. So, and the whole point here is we're just starting our route with some value that's not one of our hotels. Okay. Now let's talk about getting the values into the distance array. Ooh. We could kind of build it right onto this one. Let's make another loop. We'll need another variable as well. So I'm going to declare another variable here called y. Dim y as an integer. And let me come down here and make another array. Another loop. For x equals 0 to hotel count -1, just like we had before. For x equals 0 to hotel count -1. Next. And let's go ahead and get our distance array populated, at least started here. So distance sub something, I'll come back and put those in here in just a minute, equals, and let me read across these values right here. So the first time through the loop, so I'm going to stay here on row number 2, and I'm going to start at column 2, column 3, column 4. So distance equals my distance sheet dot cells. I'm going to fix on row number 2, and my column is going to be x plus 2. Okay. So now here, I'm going to put this in, if I'm going to think of this as, kind of columns and rows, let me put this in row number 0, column number x. So I'm thinking about having my whole array built here. And now at this point, this loop is only putting across the first one, right? We're sticking only on a 0. For my ordered pair, I'm only giving it a 0, but then I'll give it a 0, 1, 2, 3, 4, 5, all the way through 36 here. So I'm doing 1/36 of the problem, but it's only that first row going across. And I'm reading the values off the worksheet. This is a little bit more complex because I've got 2 indices I've got to manipulate. But you'll notice that I'm sticking on row number 2, and I'm sticking on kind of row number 0 in my array. So far, so good? Let me go ahead and run this up to this point. I'm going to put a stop right here so I can kind of go snooping around. I'll run that. So now my distance array has been filled up. I should be able to come to my immediate window. Well, of course, you could also look in your locals window. It's too small to see on the screen up here, but you can look at your locals window, and you'll see the whole array that you can kind of explore through the array. But let's take a look at it here. Distance. Now, the only place I ever wrote was row number 0. So let's look at row number 0. But then let's also look at column number 1. And we see 691.13 in there. That's this value here, 691.13. Next one over is 374.37. Let's look at column number 2 in the array, 374.37. So it looks pretty good. Let me go ahead and bounce all the way out to the end, or part way to the end, 32. I've got another number out there that looks pretty good. But any other row that I look at, I haven't written to yet, so it should just have the zeros in there. So I'll put a 1 here. That's just 0. I look here at row number 15 in my array, still 0. So at this point, my code has only written across that first row. That is what, that's what this loop is doing. Question? What's in the 0, 0 position? Let's take a look. 0, 0. You might not be surprised to find out that it is 0. So 0 is there. Now, how did that 0 get there? Is this the same kind of 0 that we have here? Well, it's 0. I guess I don't know how many kinds of 0 there are. But how did this 0 get set? How did the 0 that we just printed off here, where did that 0 come from? No, because look, this is 1, 0. This is not a hotel to itself. This is the next row down, which we haven't written anything to yet. So where did that 0 come from? Default value for single type is 0. But when I looked at, the first time this code executes, x is 0. So I actually wrote something into 0, 0. And so if I go look here, I say, hey, there's no 0 there. That's blank. That's a 0-length string. Why did it go 0? That's VBA looking at what you're doing and going, oh, you poor, sorry programmer. It doesn't make any sense to assign a 0-length string to a single type variable. It's not a number. And so the guys who wrote the interpreter, they got 2 options here. They could say, just give an error and say this is a type mismatch. But what do they do instead? Well, a 0-length string, that's nothing. That's kind of like nothing in numeric, which is 0. And so they literally just said, you know what? You want to assign a 0-length string to an integer or to a numeric value? Great, we'll do it 0. That's really what happened there. So it was 0 before as a default value, and we wrote right over the top of it. What do we write? 0. So that's a happy coincidence for us here. It makes the code a little bit simpler that assigning a 0-length string to a single type gives you 0. Because that's the value we want there, isn't it? Yeah, that really is the distance between Salt Lake and Salt Lake, 0. It's the same place. Okay. How many of you are so far going, arrays? Not too bad. I'm feeling okay. Maybe not totally comfortable, but I think I'm following it. Okay, buckle in for the last 5 minutes. Because now what we have to do is we have to do this. We have to do what we just did 36 times. Right? We've got the first row of our array populated. We've got to do it. We've got to do all of them. So I'm just going to tab that in, and I'm going to make another loop on the outside of it. For y equals 0 to hotel count minus 1, the same size in both dimensions. I will put a next here. There's actually kind of an interesting little syntax that you're allowed to do here. You can put the name of the control variable here if you want to. I never do it unless I'm nesting. But you can actually just put next x, next y. You used to have to put it all the time, but they said, oh, you don't really have to do it. Okay, so now my inside loop is going to execute exactly the same every time, but this whole loop is going to go 36 times. So let's think about it. I come in here, I set y equal to 0. Great. I come in here, I set x equal to 0. And now I'm going to put in here, I'm doing nothing with y here. This line is going to be the same with respect to y, the same every time. It's going to change its x value, but we've got to change its y value. So what are we going to do? Yeah, let's just change this to be y. And let's change this to be y plus 2. Right, because my numbers they're just offset by a blank row and indexing starting at 1 instead of 0. And so that should now fill that array up. Let's go ahead and I'm going to stop my code and run it again. Did I stop my code? Run it again. And so now if I look at distance 0 sub 5, I get something there. But now let's look at row 1 sub 5. I've got something there too. So let me go to like row 4 sub 5. Yeah, I got something there too. That looks pretty good. What if I go to row 6 sub 5? I got nothing there. Why not? Yeah, because now I'm further down here and I'm not getting over far enough to get into these numbers. Right? I have just read this right off the sheet and put it into the array. So everything down here is 0. These are all zeros. Well, I would like to set this up so that I have numbers going all the way across. Because what I have to do in this algorithm is I've got to say, all right, I'm sitting here in Scottsdale. I want to find out who the closest city is. I just want to go across that whole row of the array to look at my numbers. So, can we do this in less than a minute? How do we get the other whole half of this array to fill in with these numbers instead of what we have here? And the answer is, every time we write to row number 0, column number 1, where else do we want to put that? When I'm in 0, 1, I want to put that same number in 1, 0. I just have to reverse the indices. So let's do this. Instead of starting my x off at 0, I'm going to start it off at y plus 1. So that's hurting, isn't it? So there's no reason for me to read, when I'm on row number, or when I'm on, let's see. When I'm on row number 0, there's no reason for me to read column number 0. It's a 0. It's already 0. So I just want to be offset by 1. And as I increase the rows that I'm going down, and go across the columns. And it actually works either way, everything in rows or columns. I'll just do one more thing here. And that is, every time I write to x comma y, I'm also going to write the same thing to y comma x. I'm just reversing the indices here. You may feel a little bit better on this if you actually kind of spend more time than we have here in class to kind of go through and see why this works. But if I look at 6, 5, that gives me 22.99. If I look now at 5, 6, I get the same number. So we're saying now, don't read across the whole row, just kind of read across the place where there's the numbers, and every time you write to a cell, write to its analogous position on the other side of the array. So at this point, we've got the arrays set up. So we've got our distance set up so it's fully populated. We've got the names of our hotels, and we've got our route specified to a bunch of values that we know are not referring to a hotel. Okay, let's call that good for here, and next Monday we'll finish off this example and get a little more practice with arrays. Probably the hardest homework that you have to do is the next homework. So we do Monday. It's asking you to do What's due Monday? Yeah, smallest number. I'm actually having you think through part of this next part of this problem, and I'm having you work with arrays. And so that's probably one that you don't want to wait till the last minute to do. Maybe get together and with someone and kind of think through it before Monday. All right, thanks for coming. Class dismissed.